I'm Dwayne Friend. I'm with University of Illinois Extension, and on behalf of myself and Hans Schmitz with Purdue Extension, we welcome you to this webinar series. I'd like to introduce Dr. Trent Ford. Trent is our Illinois State climatologist, and he provides weather and climate data, maps, and information for farmers, government agencies, policymakers, and citizens. He also conducts research on past climate events, monitors current conditions, and studies possible future climate change, and acts as the state's authoritative spokesperson on climate science. Today, he'll be discussing climate change and the roles of soil and water conservation to improve long-term profit and resilience. With that, I'm turning it over to you, Trent. Welcome.
Yeah, thanks. Can you see the presenter mode, or are we in full screen mode for everybody's screen?
I'm
all good now.
All right. Thank you very much. Yeah, and sorry for the delay about that. I was actually at a different extension event and coming live to you from the extension office in Collinsville, Illinois. So yeah, thanks Dwayne and Hans for putting this together. What I'm going to do today is what I've been told to do is give a background kind of to kick off this seminar series or webinar series and talking about climate change kind of broadly and then specifically the impacts to agriculture. And this is sort of modeled after a talk that I gave at the crop management conference last year for Illinois that really kind of seeking to talk about what we know about agriculture in a changing climate, what we don't know, what we're maybe uncertain about, and then the kind of things what we can do. So a little bit of problem, hopefully a little bit of solutions as well. And ideally, this will set up the next string of talks that go more into, hey, what can we do about this? So I want to kind of lay the groundwork here of thinking about the past as a predictor of the future. So I have here a statewide corn yield for Illinois with the trend that we can see there since 1980. And the idea here being that when we think about the future as far as agricultural production in the state of Illinois and Indiana, the Midwest in general, how well can we use the past as a predictor? Certainly over the last 40 years, the climate has been conducive to high productivity for corn, for soybeans, for fruit and vegetable growth. And of course, technological advances have really been the main driver of this long-term trend. However, the question is, with climate change, what are we going to see? Unfortunately, what I've seen a lot of, or at least more than what we should see, is sort of guessing about how climate change will affect agriculture, and the two sort of scenarios that I see the most when we think about the kind of future production is either the rosy or optimistic scenario, where we have continued technological developments, maybe even accelerated technological developments, as well as beneficial climate change. Thinking about expansion of the growing season, maybe less drought, things like that. So kind of an increasing or maybe even exponential change in yields. And then I see the other side of that, which is detrimental climate change, maybe even catastrophic changes in our climate with a lack of technological development. Now, the idea here being that that either climate change is entirely beneficial or mostly beneficial, or doesn't matter and technology will outweigh it, or it's entirely detrimental and agriculture in the Midwest will change for the worse. Now, there's a lot of uncertainty here, and we can think about the empty space here between the yellow and the red lines as sort of reality. What will actually happen? The point of this talk here, what I want to lay out, is that these sort of scenarios, either everything's great or everything's terrible, are usually overly simplistic. And they usually only take into account the hazard kind of change with climate change. That is what's often called the acute changes in heavy rainfall, changes in extreme heat, things like that. They don't tend to take into account the more complex or chronic changes, things like changes in pest management, for example, that comes with climate change. So my goal here for this talk is not to give you a different line of estimating what agricultural productivity will change in the Midwest with climate change, but to lay out sort of the interesting, complicated, and in many cases kind of interconnected ways that climate interacts with agriculture, and that climate change has, or it maybe possibly will impact ag into the future. So that's just kind of setting that up. Now, if I'm talking about climate change in Illinois, this is sort of the, not even the elevator pitch. This is like the going up one floor pitch. Warmer and wetter is what we're looking at. The left plot shows statewide average annual temperatures in Illinois since 1895. The right map, or the right plot shows total precipitation. So we're getting warmer and wetter. In fact, every season has gotten warmer and wetter over this time period. Different rates. Winter has gotten warmer at a faster rate, for example, than summertime. And every season's gotten wetter. Again, spring has gotten a little wetter at a faster rate than fall, for example, but across the board, this is sort of our climate. The question, and when we look at projections from Earth system models, global climate models, just at annual average temperature, which is the maps on the left here, and total precipitation, the maps on the right, it shows a similar trend, right? That a continuation of the historical trend of warmer and wetter across, not just across Illinois, but across much of the Midwest. And of course, the difference here in these maps and the shading is a difference between projections, model projections for mid-century, so we're thinking right around 2050, and late century, right around 2080, 2090, something like that. Now, it is important, given the little call out window there at the bottom right, that the extent and magnitude of climate change, the extent and magnitude of warmer and wetter, and then the impacts that come from that, which I'll kind of lay out here, is primarily driven by human emissions. I'm going to touch on this a little bit more at the end of this talk, kind of put it in a little bit more brass tacks kind of way. But in this sense, the amount of emissions between now and the end of the century are really dictating the extent of those trends, and therefore the extent of the impacts we have to agriculture. So, that's where I could leave it, right? To say, okay, what does climate change mean for Illinois? Warmer and wetter. But of course, when talking to different groups, different interested groups or special interest groups, it's always the next question. Okay, what does this mean for so-and-so? What does this mean for Illinois agriculture kind of broadly? So I want to kind of lay out a number of ways that we've seen changes that climate change has impacted agriculture, and kind of look forward to see how those are going to change in the future. So the first thing, with the first kind of trend that we've seen, really just in the last, the latter half of the 20th century, is an overall longer growing season. So again, just for Illinois here, what we're seeing, the two maps, the one on the left is from the old agronomy handbook for Illinois, showing the average growing season in days between 1971 and 2000. Now, the growing season here is just the number of days that elapsed between the last spring freeze and the first fall freeze. That's just one kind of simple way of estimating the growing season length. And then on the same thing on the right-hand side, only that's the new agronomy handbook 1991 to 2020 average. And so what we can see here from northern all the way to southern Illinois, the growing season length has increased the difference between those two periods has increased by about 10 to 20 days over the last 50 years. So we've chunked on about an extra couple weeks to a few weeks onto the growing season, both in the spring and the fall. And the main driver of that is a earlier last spring freeze and a later first fall freeze. And this is across the board. I just have the maps here from Illinois. That's where I work, but of course it's across the board, across the Midwest. We've seen an extension of that growing season. Now, some of the impacts to agriculture from this is that it can, hypothetically, it can lessen issues from delayed planting. So we've seen that in a number of years. 2019, I can really add 2022 in some spots in Illinois to that, where we had issues with raininess, wetness, cloudiness, and it just really wasn't conducive to getting a timely planting done. Now, having more time on the backside of the growing season, knowing that September is acting more like an extension of summer than it is a new fall month, can help sort of get that late planted crop to maturity. We definitely saw that in 2019. When folks were planting 105-day corn right around Memorial Day, thinking, well, this obviously isn't going to work out very well, but the crop actually got finished because we had a very warm September and pretty mild October to get that done. One of the negative impacts from a long growing season, though, is, of course, it's not just our cash crops that like that longer growing season and the warmer growing season, as I'll get to in a little bit. It's all of our weeds as well. So, the amaranths and the water hemps of the world enjoy a longer growing season as well between those frosts. So the overall longer and warmer growing season also would likely increase weed pressure with or without changes in herbicide resistance and things like that. With a overall warmer conditions, and especially during the fall, as I mentioned, that extension of the growing season, we're also seeing warming of the soil. As expected, the air temperature changes really translate to the soil temperature changes. I'm showing here 4-inch bare soil temperature and the trend from Fairfield in kind of east-southeast Illinois. Between 1990 and 2021, you can see that trend of just the first week below 50 degrees. So this is kind of the day of, or the, I guess, the day of the first week where that soil temperature falls below 50 degrees, which can be a good temperature where we can start thinking about some of that fall nitrogen fertilizer application. What we're seeing is that trend of those soil temperatures are moving further into the fall. So our soil temperatures, because of overall warmer growing season, warmer fall, they're not cooling down as quickly in the fall. And so whereas in the 1990s, our average, first day where we would see those soil temperatures consistently below 50 degrees was sometime in the first week of November. Now, over the last 20 years or so, we've really seen that more in the second to third weeks in November. Impacts from this is really an extension of those warm soils in the fall can reduce the window of opportunity for fall fertilizer application. We saw that in 2021. In 2021, we had a pretty timely harvest, and then October was very warm. And so folks were trying to get their fall field activities done. So before, of course, the inevitable cold came in, and we saw some really not timely manure and fall nitrogen fertilizer application on soils that were in the 65 to 70 degree range. We're going to lose a lot of nitrogen off those soils, both through runoff and through a tile drainage later on in the winter with that application. So not ideal. So this is one of those sorts of management impacts. As we see warmer falls, it definitely can be conducive to finishing off a crop to maturity that maybe was late planted, but also it tightens some of those fall decision-making windows because our soil temperatures are not getting to those critical temperature thresholds as quickly. We see the same. I'm just showing fall here from Fairfield, but the spring is showing the same thing. So warming spring soil temperatures will likely also continue in coming decades, and that can facilitate perhaps an earlier planting with the right precipitation window. So again, I've got a mix effect here with warming. All right, now we kind of talked about the edges of the growing season. I want to kind of hit the growing season hard here. One of the biggest impacts we're seeing here is it's not just a longer growing season, but a warmer growing season too. Now, the plots on the right-hand side here, what this is showing is historical and then model projected changes in the annual number of very warm nights and very hot days in central Illinois. So very warm nights when we don't get below that 70 degree mark, kind of stifling summer nights, and then the bottom plot showing those hot days where we get above 95 degrees as a high. And so what those red and green areas are showing is even both under the higher emission scenario where we emit more greenhouse gas emissions between now and mid to late century, and the lower emission scenario in the green, irrespective of that, we see projected increases in the frequency of very warm nights and very hot days in central Illinois into the future. And so this does have a number of impacts to it. It does the change, especially the change in an increase in the number of very warm nights, that increases the risk of extreme heat stress on crops. Now, what's interesting about the Midwest, especially parts of Illinois and Indiana, is that we tend to not see the heat stress as much as drought stress, and the two are interconnected. We don't tend to get many days, at least historically, above 95 to 100 degrees unless we're also very dry, in which case it's difficult to parse out the impact from the heat versus the impact from the dry. What will be interesting moving into the future is if we see this warmer overall summer trend, is it possible to get 95 to 100 degree days with adequate moisture in the ground? And will that induce the same kind of heat stress that we have on crops when we're dry? It's a question moving forward. However, the likely increased frequency of these very warm nights and hot days can be detrimental, can induce some stress on crops. It also can worsen disease, insect, and weed stress. You know, it's sort of, when we're thinking about the crops, this goes with ecosystem stress as well. It's not just, you know, what's happening with the weather, but it's kind of the compounding effect of weather impacts as well as possible stress from insect, disease, and weed stress. And I'll talk about humidity here in a little bit. A lot of the increasing trend that we've seen over the last 50 to 100 years, and much of the projected trend in the very warm nights in the summertime, is due to increased humidity. And that brings along its own sorts of issues as well. And then also, we cannot forget that agriculture, both commodity crop agriculture and especially fruit and vegetable agriculture, as well as livestock agriculture, is incredibly labor intensive. So being outside with a warmer and warmer summers increases the exposure risk for farmers and farm workers to extreme heat. So it's not just a plant physiology risk and integrated pest management issue. It's also, of course, a human health, a public health issue for outdoor and farm workers. And then we have, you know, issues with drought as well. So flash drought is one of these you know, is one of these kind of emerging issues that we hear more and more about, especially in the media, but also on the scientific side, more in the science as well. Now, I will say, kind of that first blue plot up there, the blue call out window, that, you know, that wetter trend that I mentioned at the beginning of this talk for most of the Midwest, that wetter climate has equaled fewer long-term droughts overall. It's been many decades since we've seen droughts that have spanned multiple seasons with impacts akin to years like 2012, 1988, and then of course the decades-long droughts in the 1950s. Just take into account this year, or I guess coming into this last fall, when we were coming into the winter with a pretty significant drought. The map on the right-hand side, the U.S. Drought Monitor map from October 25th, shows severe to extreme drought in southern Illinois. That has really only lasted a couple of months. We've come out of that fairly quickly because of a near normal to wetter than normal January. That's brought us a good amount of replenishment for our soils. So it's not necessarily the long-term droughts that we're super concerned with in the Midwest, especially from an agriculture standpoint, but instead the droughts that are induced by relatively short dry spells. We're talking a handful of weeks to maybe a month or two, that are exacerbated or worsened by this warming trend. So warmer summers induce overall more evaporation. And what that can do is exacerbate soil moisture issues or soil moisture deficits when we do go dry. So the warmer summers push us into drought, and push us into drought impacts, especially to agriculture, faster when we go dry. So the idea here, there's a bit of nuance when we think about drought as it relates to climate change in the Midwest. It is likely that we will not necessarily see an increasing frequency of drought as we think about it today. However, when we do go into drought, the overall warmer summers mean that it comes on faster, and we go from things are okay to, hey, we're seeing impacts much more quickly. And so, of course, that again shrinks the time available for management, perhaps for irrigation scheduling, water management, things like that. So this is one of these things where it's not necessarily saying more drought or less drought is the right kind of way to frame how climate change influences drought and agricultural drought, specifically in the Midwest, but instead it can change the characteristic of drought. So the impacts, of course, crop stress from high evaporative demand and depleted soil moisture. We saw that in pockets in 2021, especially in northern Illinois, and then this year in 2022 in the Champaign area in eastern Illinois, and then later in the growing season in southern Illinois. And I just want to make the point that drought stress is, of course, made worse by poor soil health and poor water holding capacity. And that's a kind of a theme that I hit on as we keep going in this talk, that soil health, we tend to see the most resilient systems, farm systems, during drought be on with those with the healthiest soils, or those that have implemented years, if not decades, worth of soil conservation. I mentioned humidity. what I'm showing you here on the right-hand side, this is the trend in dew point temperature, which is one of the better indicators of humidity. This is summer dew point temperature in Belleville, which is in the St. Louis Metro East area. And you can see that consistent increasing trend. It's representative of the entire state. Summers have become more humid, and they're projected to continue becoming more humid. We have the same sort of farm labor issue. Of course, when your humidity's high, and coupled with those high temperatures, that creates a real a big human health issue. But also some of the other impacts from humidity is it creates a welcoming environment for insect, weed pests, and especially fungal disease. Gosh, we saw this all over the state in 2021. I don't know if I've ever seen tar spot as prolific. And one of the big reasons being is that, we would reach our dew point every single night, which means we'd have heavy, thick dew on the leaves every single morning. Really in my garden in Champaign up until like 11:30 in the morning, we'd have that thick dew on the leaves, and that just really conducive to fungal disease. I do mention that humidity can slightly offset impacts from drought. We did see that in northern Illinois, where we weren't getting the incredibly high, I guess incredibly low dew point temperatures, but that is a very small effect. I think the biggest effect from increasing in humidity is really that fungal disease pressure. And then other impact here is wetter springs. I would probably argue that this has been one of the biggest impacts that we've seen to agriculture so far, negating any sort of future projections. Just in the last 30 to 50 years, this increasing trend of wetter springs, wetter overall and more intense precipitation has been problematic. Spring has gotten wetter across the Midwest. It's expected to continue getting wetter at a faster rate than all other seasons. And of course, in many places in the Midwest, spring is our wettest season overall anyway. You can see here the standing water in Bureau County in June of 2019. But, gosh, we've seen spring fieldwork delays due to excessively wet soils in almost every year in the last 5 years. And again, that really negates the beneficial impact of expanded growing season. So we can say, hey, you have more time in the spring because you're getting your last frost, or you're getting up to those critical soil temperatures earlier, so you can plant. But oh, by the way, your springs are getting wetter as well, so it really complicates that possible beneficial or benefit from an expanded growing season. And of course, we have lots of impacts from that. Disease pressure can be problematic when we have a wet spring, but also when we try to quote unquote mud it in or get that field work done despite the wet soils. We have issues with soil compaction. I mean, that's essentially permanent damage, really bad germination and emergence. We saw that this last year. Folks that were able to get their crops in April. I don't think we saw the sun more than 2 days last April, and that really led to some pretty bad emergence, and then of course leading to replant. And so this is one of those trends, this historical trends of wetter springs that is robust. We see it pretty much all across the Midwest, and it's one that for all of the uncertainty that comes with projecting changes in rainfall with climate models, this is one that climate models really latch on to and have a lot of confidence in continuing that projection of wetter springs. And if I were to say, overall, Illinois today is 5 inches wetter, gets 5 inches of more additional precipitation than we did back in the turn of the 20th century. That wouldn't necessarily be a bad thing if that rain was well timed, ideally, late summer as opposed to spring. But one thing we're also seeing is a change in the characteristic of the precipitation. It's not just that we're getting more rain, but we're getting more intense rainfall. So more heavy rainfall. That's especially the case in spring and summer when we have the right mechanisms to generate that heavy rainfall. You can see just in June 2021, this image of this flooded out field in DeWitt County. This is not in a floodplain. It's not in a mapped floodplain. This is just because that area picked up about 6 inches in something like 12 hours. And it doesn't matter. It really, at that point, it doesn't matter how healthy your soils are. You're going to have standing water. And then, of course, the next day it reached up to 95 degrees. So essentially, a lot of these corn plants were just boiled alive. Just put a number on it, because as a climatologist, as a stats nerd, I have to have numbers. St. Clair County, which is where I'm sitting right now, actually, in in the Metro East part of Illinois. Just to pull a statistic here, the likelihood of getting at least 4.5 inches of rain in a single day in a 24-hour period in St. Clair County has doubled since 1989. So we did the original Bulletin 70 estimates of rainfall frequency, storm duration in 1989. It was just updated in 2019 with the new Bulletin 75. So we have kind of the 2 points we can see how the intensity of rainfall has changed, and that type of event went from essentially a 5% chance happening any given year to a 10% chance of happening any given year. So of course, this wreaks havoc with urban design when you're building your retention pond to a certain level of precipitation, and it's doubling. But also for agriculture, what this really means is that we're just getting more intense rainfall, and the impacts. Crop inundation and standing water, pretty much every year we've seen that. When the crop isn't on the field or recently planted, recently harvested, we get that heavy rainfall on bare, fallow ground. It causes some really serious issues with soil erosion as well as nutrient runoff. And that goes also back to that the shrinking of the timetable for applying nutrients in the fall because of those warming soil temperatures. Not following those guidelines can lead to even more of that nutrient runoff, which is, yes, an environmental issue, but also, of course, an economic issue as well. Just a bit more about the problems with changing precipitation, because like I mentioned, this is really far-reaching impacts. Heavier rainfall produces more runoff. That does a couple of things, as I kind of alluded to in my previous slide. We get soil erosion, especially off of more of those sloped surfaces. There was a study back in 2021 that estimated that Illinois has lost about 25 to 35% of its organically rich A horizon to erosion since the 1850s. They put an economic number to that. It was something like between $10,000 and $40,000 per farm per year that we're losing in kind of the top end yield. So it's sort of unrealized losses just due to soil erosion alone. We also get more nutrient runoff. As I mentioned, that's real. It's a real problem, right? It's a problem environmentally because those nutrients are running into our streams, our rivers, our waterways, our rich aquatic ecologies. But it also means that there's less nutrients for your crop. So it affects the bottom line yield as well. And sort of paradoxically, heavier rainfall also puts us at a higher vulnerability to drought, because if we get 4.5 inches of rain in a given day, the soil may only net a very small fraction of that, while the rest runs off into our rivers, down the Mississippi and out into the Gulf, where it can't really do any good in subsequent drought. So even getting the same amount of rainfall or even slightly more rainfall in the summertime, we can actually be at a higher risk of drought impact because that rain is coming more intensely. We're not able to net it. So this is really, again, when I mentioned that those with the soil conservation practices that are so important for many things can also reduce vulnerability to drought by increasing those infiltration rates, getting more of that heavy rainfall into the soil, less is runoff. So those can be really important in that sense as well. And then, of course, wet soils. I mentioned before those spring fieldwork delays due to excessively wet soils. Again, despite the expanded growing season. I mean, these are just pictures of some pretty not ideal situations. I mean, those ruts in the field on the left that's going to be a problem for years. So the soil compaction really affecting the long-term soil health. And again, this is really about climate change shrinking those decision-making windows, shorter windows, tighter windows, because of wetter springs overall, meaning that we have to get the same amount or even more work done in a shorter period of time. And so this is kind of where the nuance comes in. As I mentioned at the beginning of the talk, when we're talking about climate change in agriculture, it's not doomsday and it's not don't worry about it. It really just complicates things, and as I'll talk about in the end, it really makes the decisions that we're making already on a day-to-day, on a week-to-week, on a year-to-year basis that much more important. And it's just a factor we need to roll into our considerations of our management decisions. Okay, so that was a lot, and sometimes I can be doom and gloom, so I want to pull it back and kind of add some perspective to this. Okay, so now, great, okay, all this is happening, what do we do about it now? Okay, big thing, the topic I hit first and foremost is the importance of soil health for water management. And that is in both cases, too much water and not enough water. and that variability that's so important. I'm just showing here a figure from a meta-analysis, meaning it's taking in hundreds of different studies. It's not just one case study in one field. It's taking in hundreds of different studies from around the world, not just in the Midwest, and they assessed essentially based on all of these studies how these different practices that are on the vertical axis here, how they generally influence infiltration rates with these conservation practices. And again, soil infiltration rates are really critical because during the wet periods of time, it gets your water into the soil, into the deeper layer root zone. So you're not getting as much runoff. You're not losing as many nutrients. You're not losing as much topsoil. And then during drought years, the rain that we do get gets deeper into the root zone, and it's there for the crop to use as opposed to running off and not being there. And so those infiltration rates are extremely important. And what we see here is that based on this meta-analysis, based on dozens and dozens of studies, that cover crop use, crop rotation, and perennial systems show the most promise in boosting those infiltration rates and soil health more generally. I don't like to dabble in the soil biologic standpoint because I'm so far removed from that world, but the studies that have been shown, the presentations I've seen is also these kind of practices help with the biological soil health as well. The impact of tillage practices seems to be a bit mixed, and that's not just based on this study, that's the studies directly from Illinois as well. It tends to depend on climate, your tillage extent, your depth, your residue management. So for example, what a lot of these studies that this paper found or cited was that having the residue there makes all the difference in whether conservation or no-till actually improves your infiltration rates. And so that can be really important as well. One key point here is that all of these management practices that are touted for many different reasons, many different benefits, all of these management practices are long-term solutions. And it's really, they need to be thought of as long-term solutions to maximize your economic and environmental benefits. It's not something that you can do for 3 years in a row and then just not do for another decade. And what we see kind of across the board is that the biggest benefits economically and environmentally are from those systems that have been implementing a lot of these practices for 10, 15, 20 years. And I will also say that it's important to note that even just in Illinois, and if we throw in Indiana as well, we're talking about a pretty diverse set of systems, small versus large farms, a lot of different topography, many different types of soils, and a lot of economic differences in economic means. And so what that means is that not all of these practices are right for your system. Or a specific system. There's not a silver bullet here. The idea is that just as you would manage for a new emerging pest, disease, as some sort of issues with technology or policy change that makes your practice more complex, this is what climate change does as well. And so just as there's no silver bullet for water hemp herbicide resistance, there's not necessarily a silver bullet for climate change as well. And so some of these practices may work better on your farm than they do on others' farms, or not as well. It's really about rolling these in, some of these in, trying these out for management practices to be resilient to climate change. Some may work, some may not, and that's kind of having that menu of options is really important. All right. One of the things that I wanted to mention too, in thinking about solutions, is pest management. More standing water from intense rainfall, more humid summers, making that really welcoming environment for things like tar spot, fungal disease, and then of course more rainfall variability can reduce, has been shown, possibly some research here at the U of I, to reduce the efficacy of early and late season weed control. And then of course connections between the wetness and insect pressure are a bit less well known, but they may be there. What this really means is that it really heightens the importance of integrated pest management. Of course, not just relying on herbicide control, but entirely integrated pest management, but also things like scouting and apps like Tar Spotter, for as just one example, that can become really important for those decision making. So proper timely scouting for things like Tar Spot can make a world of difference. Now that's true today. Integrated pest management, proper scouting of these diseases can make a huge difference. What I'm saying is that with the change in the climate, it doesn't negate those strategies for dealing with pests and diseases. It makes them that much more important. And so, the importance of these sorts of techniques is just increasing as we see warmer and more humid summers and things like that. And again, just as it with soil and water conservation and soil health, there's not a silver bullet when it comes to managing pests, diseases, and insects. It's really kind of across the board. One tool I wanted to highlight here, so sort of a shameless plug, is the CoverCrop Analyzer. This is something that's been developed at the U of I, as well as with support from NREC. And what it does is allows folks to basically model out in real time the sort of potential benefits of a cover crop system on their farm. So you can select where your farm is, the type of cover crop, your planting date, and potential cash crop planting date the following spring, and it'll run the DSAT model in real time to give you an estimate of kind of carbon to nitrogen ratios, biomass estimates, things like that can help you kind of sort of plan for when we want an ideal termination of those cover crops, either during or before the spring cash crop planting. Now, one thing that I'm sort of involved in this project with is integrating a bit more of a clever weather component to it. So right now we're using historical information, like what is the average spring, that sort of thing. And so ideally we'd be pulling in forecasts, near and medium term forecasts, to give you an idea of, okay, we're looking at this type of outlook, a wetter or a drier than normal outlook for the spring. How does that change biomass, for example, growth? How does that change carbon uptake rates and nitrogen uptake rates, things like that? So this is a really neat tool. It is free to use, yeah, it's a great. It's just one tool in many that can help sort of demystify some of the challenges behind cover crops. Others, as I mentioned, tar spotter, as well as the corn in pipe. That's again, these are tools that they're not silver bullets in and of themselves, but they can really help with some of these decisions that, again, with climate change is just making these sorts of pest and insect management decisions that much more important. And then last shameless plug, I promise, this is the Illinois, the State Water Survey, the Illinois Climate Network's Pest Degree Day tool. So we have our 19 mesonet sites there, the map on the left-hand side. And at each of these, we're keeping track of degree day accumulation for a number of both like commodity crop pests as well as ornamental pests, and we're hoping to get some green industry pests as well on there. So you can see, and this is updated in real time, the accumulated degree days for corn rootworms. And I just took an estimate here of where we were in 2017. This is Kelly Estes with Extension and the Water Survey. Her work, as well as Jenny Atkins. And this is, again, updating real time to give producers an idea of, okay, here's how temperatures have stacked up so far. If we're in late May, early June, early July, here's where the type of pests you should be scouting for, and here's kind of the life stage that they're in. And this has been really, really helpful for both, again, the commodity crops and specialty crops. And certainly, play around with this. And if there are insect pests that you would like to see added that aren't on there already, definitely reach out to us, because I think this is a tool that has a lot of potential to expand. Okay, so brass tacks here. This is sort of my conclusion slide, and it's going to be my wordiest slide, but just bear with me here. So the summary for climate change in Illinois: all seasons have gotten warmer, all seasons have gotten wetter. We have more variability in certain situations. The more intense rainfall, I would say that's been one of our biggest impacts so far, causes issues with standing water, runoff, and actually, like I mentioned, paradoxically, kind of drought vulnerability as well. Increasing growing season temperatures, warmer growing seasons overall, plus the humidity. I think the humidity is one of the bigger drivers here. Increased disease pressure and as well as heat impacts, and we've seen that in prior years. 2021 again coming to mind for its humidity impacts. Warmer winters are kind of a mixed bag. We have certain aspects of warmer winters. I just talked to a group of horseradish growers, and the potential of fewer days with frozen soils can be more conducive to timely spring and winter field work. But on the flip side, warmer winters are also more conducive to pests and disease overwintering, which is something that we're seeing in some pests, not all, but something to keep our eye on for sure. And then just the point that our climate models project worsening conditions by mid-century. We're talking about 2050 here, especially in the spring. So these trends that I've kind of picked out are not only trends that I think are important for agriculture, but are also trends that we're likely going to continue to see into the future. So this is something that isn't necessarily going to go away. And it's likely, again, making those decisions that much more important. And again, just plugging out soil and water management is so important here. What climate change really does here, again, is makes these important decisions that much more important. It comes to integrated pest management, soil water management, nutrient pesticide application, grazing, rotation, soil conservation, planting and harvesting, storage, and then even marketing strategies. Because of course we know that climate change is not just an Illinois and Indiana issue; it's a global issue. So we have problems, with weather variability and volatility in places like Argentina, Australia, Brazil, that cause issues with marketing here. Or as maybe as a more pressing example, what happened this last year in the lower Mississippi Valley, which wasn't necessarily a centralized drought issue, but more of a regional drought issue that definitely messed up basis and all sorts of other things. And then the kind of last bit here on this slide, I have the 3 pillars of sustainability up there, and I like to always put this up here because sustainability has kind of taken on a form of representing primarily one pillar, and that's the environmental pillar. And that is an extremely important pillar of sustainability, but in reality, there's 3. There's social, environmental, and economic. So, we need to understand that sustainable agriculture sustains all 3 of those pillars. And this is one way I like to kind of frame climate change, is that when it comes to the solutions, the management activities that make us more resilient to climate change is similar to reacting to any sort of, as I mentioned earlier, emerging sort of threat to agriculture, whether that be through marketing issues or through a new insect pest or disease. The management practice decisions need to account just like any other challenge. The question being, for producers is this decision that I'm making, or is this action that I'm taking or not taking, making my operation more or less vulnerable and profitable in the face of climate change? If the answer is no, then my message to you is that these issues that we've seen are likely going to get worse, if not just continue into the future. And so that makes those decisions that you may or may not be making now that much more important going into the future. Okay, last bit here. I talked a lot about kind of the adaptation side of things. Climate's changing. There's impacts to agriculture, good and bad, a lot of bad, but we need to adapt to those changes. But we also need to understand that we can mitigate climate change as well. The primary problem here is caused by emissions of greenhouse gases, primarily carbon dioxide. So reducing greenhouse gas emissions, this isn't just an agriculture sector thing. Agriculture plays an important role in this, but all sectors reducing greenhouse gas emissions equals fewer and less intense impacts in coming decades. And that's a global problem, reducing global greenhouse gas emissions, but the impacts are local here in Illinois. So what we did, Liang Chen, who's now at the University of Nebraska, and I, what we did is we looked at the sort of impacts of climate change by 2050 with 1 degree Fahrenheit less global warming. So if we say, here's where we're looking at right now, what if we just decrease that by 1 degree Fahrenheit through fewer greenhouse gas emissions, sort of the impact of mitigation. And what we see is in Illinois, an average of 15 fewer extreme hot days per year with that mitigation effort. That is 15 days where we don't get above 95 degrees. The wettest 5-day period of time in the year is 3.5 inches less than it is with that extra degree of warming. And we have an average of 1.5 fewer months per year in drought, just again, from that warming. So, when we think about climate change, a lot of the action that individuals can take is in the adaptation realm. How can I prepare myself for these things? But also we have to think about low or ideally no carbon sorts of systems that can help contribute to the mitigating or fixing the actual problem of climate change. So with that, Dwayne, I hope I left enough time for questions. I'm happy to take any and all, and my contact information is here. And I'm really happy to, answer questions, talk to anybody about these sorts of things, hear what's going on. So again, Hans and Dwayne, thanks for letting me talk today.
Trent, thank you very much. That was great information. So again, anybody that's got a question can put it into the chat box and we'll get to it. While we're waiting for some of those questions, as you can see, we've got a poll here, if you wouldn't mind doing that really quick as well. But one of the things that I was going to catch your thoughts on, when you look at those lengthening of the growing season, and especially in the springtime where we're getting earlier and earlier when that starts, what are there the same chances as there's always been in terms of having that outlying late frost, or has that become more of a concern or less of a concern?
That's a good question. Yeah, I get this a lot when talking to specialty crop growers. It's great that we have this trend in earlier last spring freezes and later first fall freezes, and especially in the spring freeze. That's where really we see those problems. The issue is that that's sort of the average. But over a 30 or 40 year period, but it doesn't necessarily account for variability. There is kind of mixed information, mixed data, mixed results out there about the variability of freezes, both spring and fall freezes. So I wouldn't, right now, there is not enough information. I haven't seen enough results or generate enough results to say with confidence that our spring freeze dates are becoming more variable. Which would lead to this idea of, on average, they're earlier, but we can get a late one. But that is something that is kind of what we're watching, both in projections and the historical trends, to see if that's the case, or if the mechanisms for those late spring freezes are still around. So there's a lot of debate on the climate side. I will say, though, Dwayne, that part of this issue is the climate, the weather in the atmosphere. Part of it is the plants. So even without a change, even with a decrease or like a earlier spring freezes, if our winters continue to warm like they're projected to, it means that we could see earlier dormancy breaks from some of our perennial crop systems. And so it's not necessarily that we can get those late spring freezes like we used to before, but that if we're breaking dormancy 2, 3, 4 weeks earlier, it just inherently puts those systems, those peach trees, those blueberry bushes at a higher risk of having those freeze damage. So it's the spring matters, the winter matters, and it's something that I think it needs a lot more work to kind of flesh that out and give more concrete information to growers across the Midwest.
All right, thank you. Next question we have that says nutrient reduction is going to be an increasing problem with more intense rain. How do we address this?
That's a good question. A lot of those soil and water management techniques that I talked about, I didn't even talk about edge of field practices, but in-field practices are really important to reducing nutrient loss with or without climate change. So that's a big one that producers can do right now. So when we think about things like, I'll be honest, when I go to these extension events or Farm Bureau events, and there's speaker after speaker after speaker after speaker, it always helps me to make my point when each of those speakers has said, here's your problem, from a pathology standpoint, from a entomology standpoint, from whatever else, here's the benefit of cover crops, right? So all of them kind of hit on the benefit of cover crops. So the impacts of climate change and on nutrient loss reduction or nutrient loss increases is one important reason to implement strategies like cover crops, but there's many others. So we kind of think of it as one additional reason to do that. So that is one solution. there's been kind of this discussion of individual actions versus, regulation and policy for nutrient loss. I know there's a lot of discussion about that right now, but when I come into the room and talk about that issue, my perspective is this isn't something we should sweep under the rug, because this is going to get worse if we don't address it.
All right, on to the next question. Do you think it's possible for these warmer, wetter trends to entirely push the possibility of growing food-grade wheat out of the state?
That's a tough question. I don't think so. I'm from an Illinois perspective, we do grow wheat all across the state, but still the heart of that wheat growing is in South Central Illinois. And so those warmer, wetter trends may shift the kind of ideal growing region a little bit further north, but I haven't seen evidence that it will make it, the Illinois climate conditions, like impossible or even a lot less conducive to growing wheat. A lot is made about studies that look at kind of the shift of the Corn Belt, the potential shift in the Corn Belt, for example, north into places like Wisconsin, Minnesota. But again, a lot of those studies are based off of like a growing season average temperature, and they don't account for the variability, the issues with the changes in spring frost, the precipitation, those sorts of things. So I haven't seen kind of compelling evidence that, a lot of the crops that we grow today in Illinois won't be able to be grown, into the future.
Again, if anybody else wants to put a question in there, you're welcome to do so. I'll give you one more question at least, though. When you were discussing humidity, and you mentioned you did a very good job of describing how it's going to do a number, especially at nighttime, in terms of fungal diseases. With that added humidity during the daytime, what does that mean in terms of maybe giving a little bit of tendency to keep our daytime high temperatures from creeping up even higher?
Yeah, it does. It does a number. So yeah, humidity works to sort of I don't know, reduce what's called the diurnal temperature range, the difference between the daytime high and the nighttime low. So if we have a lot of humidity, and especially if we have a lot of cloud cover, but just a lot of humidity, our daytime highs tend to be a little bit lower, and our nighttime lows tend to be a bit higher. So it's a little bit of a depressed range. And so, so that's one thing, that under an abundant amount of moisture in the ground with higher humidity, we will see those higher temperatures during the daytime depressed a bit. And actually, Dwayne, this is one reason, this is a good question. It's one reason why we haven't seen the significant increasing trend in daytime high temperatures in the summer that we have in the nighttime. So over the last 100 years across the Midwest, and just specifically in Illinois, our summer nighttime temperatures have increased at 1.5 to 2 times the rate of our daytime temperatures. Both are increasing. We're warming across the board, but the nights are warming faster, and a lot of that is that humidity effect. And so this is kind of one of the reasons I talked about the potential benefit of humidity during the daytime to sort of offset some of those issues from extreme heat and maybe even drought. But I haven't seen a lot of work actually done on that to demonstrate that a humid year is inherently, more beneficial for the crop growth during the day than a non-humid year. So that would be kind of interesting to see.
Trent, thank you so much. Great way to start out this webinar series. So really appreciate everything you did. Thank you very much.
Yeah, thanks, Dwayne. Thanks, Hans. Thanks all for being with us today.
So just to give you some information on next month's webinars, you can see up there our guest next month, which will be on February 23rd, will be Midwest Regional Climate Center Director Beth Hall. She's going to highlight some of those key value-added products that they have available, and this is going to be specifically for ag producers and businesses. Also going to discuss climate data and monitoring resources that may benefit planting and yield. And as you can see down there, and you may have noticed that when you go in to register for these sessions, you can register for multiple sessions, but here's the address if you need it again, at least the short URL for it. It's go.illinois.edu/climate webinar. glad you attended, and hopefully see you again next month. Hans, thank you so much for everything you did as well.